But I can generally comment on this that just remember that this is a science subject. This is what I told you when I commented on your answers as well, that it's a science subject. You have to be really clear, you have to be really precise, and you have to use scientific words. Your answers need to sound scientific, not to use your own words. And I told you that there are no marks for expression. It's all about, I mean, if it is shielding effect, it is shielding effect. You're going to get marks for, I mean, if you use the word shielding effect, that's what the mark is for. I mean, you can express it in other ways, but the right way is shielding effect. So
yes,
just
I just wanted to
okay.
pose
Did
a
you?
2-mark question.
Yeah, but did you send it?
Yes, I think I'll send it to you privately.
So just 1 second. Just very clear with reference to to explain why the rate of the production of ammonia would be greater at a higher temperature. More molecules have the may required to. Therefore, why the rate of production of ammonia would be greater at a higher temperatures. By your answer, it's how many? It's 2 marks, right? Therefore, increase
Yes, sir, it's 2 marks.
Yes, sir, it is 2 marks.
What did your teacher say? What was the
You said that. Sorry.
what was the missing? What were their remarks?
Oh, sir, our teacher said that you didn't say activation energy, therefore you lost the one. I tried telling him, doesn't it mean the same thing? He said no.
More molecules have the minimum energy required to react. Yes. Why the? I said now. There's one thing about this. It's not even about this specific one. It's not even. I mean, the answer. I mean, your answer looks perfectly fine. Plus, it's not even about actually. I mean, because he's talking about the rate of the reaction. No, your answer is perfectly fine. It's perfectly fine. The comment should have been more about frequency and successfulness of the collisions, that they become more successful because they have the minimum energy. So that makes perfect sense. So I mean, usually when you talk about rate of reaction, right? You mention activation energy when you add a catalyst. That is when the activation energy kicks in. What is actually missing, I think, over here is, I mean, even that the more molecules have the minimum energy required. I mean, it still makes sense. It makes perfect sense. What I would have personally written was that molecules at higher temperatures have more kinetic energy, which is why they travel faster. They have more frequent collisions and more effective collisions. So that would have been my answer. But that sounds perfect.
Sure, but you had to refer to the curve as well.
Oh yeah. Oh, there's a reference to the 2 curves. Yeah. So I said that's why required to react. Was there a label of was there a label for EA?
Yeah. Wait 1 second. Let me send you the whole page.
Okay. Now it makes sense. Like if there was a label of if that labeled something called activation energy, then you would have to refer to that. Like you would have to refer to the curve and the graph. Let me just.
Sir, I've sent it to you now.
Okay,
the whole page.
Just a second.
Yeah.
Yeah, so it does have EA labeled on it, right? So you had to be. I mean, you had to point out that EA. You had to point out EA. Is that clear? Just because there was a graph given, you have to refer to the curve. That's why. Because minimum energy, you don't know.
I wouldn't have gotten like 1 mark because I said frequency and stuff.
You should have gotten 1 mark for this at least.
Yeah, okay.
But because there's a graph and there's an EA label over there, you have to refer to that specific label over there.
Yeah, okay.
Let's
Thank you.
okay, let's continue very quickly. Should be done with this. What we did yesterday last time was hybridization. I told you that whenever carbon makes four sigma bonds, four single bonds, it's tetrahedral and the angles are 109.5. I told you that carbon has four electrons in its outer shell. It's got electrons in different orbitals, 2s, 2px, 2py, 2pz. And I told you that when those orbitals, no matter what their shape is, when four atoms pull those electrons in four different directions, the orbitals and the electrons and the negative charge of the electrons, it gets pulled in four different directions, which is why the orbitals, they all change shape, because the orbital is the place where the electron is to be found. So now the electron would be getting attracted by one atom over here, one on this side, one on this side. So that was sp3 hybridization, that instead of calling the orbitals with their old names, you start giving them new names because they've changed their shapes. The four electrons are now found in some other place, which is known as an sp3 hybrid orbital. So instead of those four old orbitals, you now have four sp3 hybrid orbitals. And they're going to form sigma bonds. So this is what we did last time. I mean, is this part clear?
Yes, sir.
Yeah.
So we're going to quickly jump to sp2 hybridization. What is what is sp2 hybridization? Now, sp2 hybridization is again, we're talking about carbon, and it still has those four electrons in its outer shell. So it's got this. What were the six? So it's 2s1, 2px1, y1, and z1. So it's still the same four orbitals. Now what will happen is, when sp2 hybridization happens is, when does it happen? When carbon forms at least one pi bond. And it forms three sigma bonds. So that is when sp2, or in other words, carbon is bonded to three atoms. Or we can describe the same thing, that carbon makes one double bond and it makes two single bonds.
Wait, could you show what was the difference between sp1 or the previous one and this one?
Yeah, I'm going to explain this one first. In the previous one, you had carbon making four single bonds, right? Like one over here, one on this. So four electrons got pulled in four different directions, and they would form four sigma bonds. This would overlap, this would overlap, this would. So they would all overlap with different. I mean, like if I have a CH4 molecule, right? CH4 molecule would look like this. Like if I copy this. So the carbon's four electrons are getting pulled by four hydrogens. So if I draw a CH4 molecule, then in a CH4 molecule, who's pulling the electrons? It's a hydrogen atom that's pulling those electrons. Hydrogen has one electron in a spherical s orbital, right?
Yes.
So there's one electron in the sp3 orbital, and there would be hydrogens pulling electrons from all sides, and they would try to.
Yeah.
So they might ask you which two orbitals are overlapping in CH4. So it's an sp3 hybrid orbital.
And then this one.
Let me do the same over here. This one as well. So basically, they're going to start overlapping somewhere in the middle part over here. We did the overlapping part, but this time it's So it's going to be a sigma bond. They're going to overlap here. They're going to overlap over here. So these orbitals will overlap. They're going to pull each other's electrons and they would start to overlap. So that's sigma bonds, 4 sigma bonds, 4 single bonds getting formed. Is that clear?
Yes, sir.
Now
Yes.
I said now the thing is sp2 hybridization. Very quickly, when carbon is bonded to just 3 atoms. One example for that is I mean there are lots of molecules. One example is the ethene. Like if you look at a ethene molecule, the carbon is bonded. It's not making 4 single bonds. Instead, it's making 1 double bond and 2 of them are single bonds. So that is an example of an sp2 hybridized carbon atom. Carbon is making, it's bonded to 3 atoms, one over here, one over here, one on the other side. It's making 3 sigma bonds. Remember that each bond, the first bond is a sigma bond. So that's 1 sigma, 1 sigma, 1 sigma. And the other one is a pi bond. We can have other molecules as well. Like if I have HC, H and double bond O. So that is also an sp2 hybridized carbon atom. I mean, the first thing is to identify the sp2 hybridized carbon atom. When carbon is bonded to 3 atoms, 3 single bonds, 3 sigma bonds, and 1 pi bond, or we can say 1 double bond and 2 single bonds. Is this clear how to identify this?
Yes.
Yes, sir.
अच्छा, अब ये कि the carbon is has 4 electrons, but it's bonded to 3 atoms. So this is what happens. This is what its electrons would look like. So you got a carbon atom over here. Now, remember, it's only bonded to 3 atoms. So imagine the 3 atoms trying to bond with it. One is over here. The other one is, let's say, over here. And the third one is somewhere over here. So imagine there are 3 atoms around carbon. Now, what those 3 atoms will do is that they would need 3 electrons. So one of carbon's electrons will get pulled by one of the atoms towards this side. The other electron is going to get attracted by the second atom. And the third electron, so that's going to get attracted by the third atom, right? So 3 of carbon's electrons are going to get attracted or pulled exactly the same way, just as it happened previously in the same way. But this is going to be a fan-shaped, all the orbitals would be fan-shaped. And these would be your sp2 hybridized orbital. So you start calling them different names. So if you look at the orbitals over here, so 3 of them, they change shape because they're involved in bonding initially. So it's an sp2 hybrid orbital. This is an sp2 hybrid orbital. This is an sp2 hybrid orbital. So what I just did is I just changed their names. Instead of a spherical, instead of a dumbbell-shaped p orbital, I now have 3 sp2 hybridized orbital. Is this clear?
Yes.
Yes.
So what happens to the 4th electron? The 4th electron is unchanged. So that remains unchanged. So the 4th electron, because it's at the moment it's not doing anything. So the 4th electron is therefore, one second. So the 4th electron is still buzzing on its axis, on its z-axis. So the 4th electron, let me just make it. So that's basically your fourth electron. Now, the shape, if you want to understand the shape, it's like a fan. Think of it as a fan. And this is on the z-axis. Think of this as the fan hanging from this point. Like if you imagine a fan, think of it hanging from the top, from the ceiling, and there's something hanging at the bottom of the fan. So this is on the z-axis. It is not in the same plane as those fan-shaped orbitals. So this is what carbon looks like when it is sp2 hybridized. So one of the orbital initially remains completely unchanged. Is that clear?
Yes.
So,
Yes.
so imagine this: carbon, 3 electrons getting pulled in 3 different directions. Fourth electron, nothing happens to it. Now, let's talk about ethene. So how would ethene actually? How would ethene look like at the orbital level? So what will happen is, and remember, you have to be really specific. You have to know the 3 of the orbitals are now sp2 hybrid orbitals, while the fourth one kind of remains unchanged because there's no atom trying to pull those electrons. So this is the shape of carbon. One electron getting pulled by one atom, one over here, and one is getting pulled over here. So there's an H over here that's pulling the electron. There's an H over here that's pulling the electron. And there's a carbon on the other side that is attracting the electrons. The other carbon is also sp2 hybridized. So it's got the same thing happening. So I've got H. So both carbons are sp2 hybridized. And we're going to talk about the overlapping now. So there's a p orbital that remains unchanged. So both carbons have a p orbital that needs electrons. So what happens when 2 p orbitals are parallel to each other? What type of bond would they form?
Pi bond.
So they're going to end up forming a pi bond in the middle and on the top. So this is what happens when carbon is bonded to just 3 atoms. It's making a double bond. That 3 electrons, they get pulled in 3 different directions, while the unchanged p orbital ends up forming the pi bond. That's why you get a double bond in the middle. Is this clear to everyone?
Yes. Sure, so the diagram you drew on the top right, it's basically what's happening with this one, right?
This one?
Yeah.
Yeah, this is, sorry. So this is exactly what's going on. I just didn't draw the blue
Yeah,
ones.
you didn't hydrogen. Yeah.
Yeah, so it's just like one electron bonding over here. So it's a fan-shaped 3 bonds, right? So 3 electrons getting pulled in 3 different directions, while the fourth kind of remains unchanged. So the fourth one is involved in pi bonding. Now about this one, you have to be really specific. Like remember so they're going to be very specific about questions as well. So they're going to ask you who's forming the pi bond. So it's a p orbital overlap. So what type of overlap is happening between the carbon and hydrogen atoms? Between the carbon and hydrogen atoms, it's an sp2 hybrid orbital of carbon overlapping with the s orbital of a hydrogen atom. Then they can also ask you about the middle one, like I mean, they can ask you about who's forming the sigma bond in the middle. So the sigma bond in the middle is getting formed when an sp2 of hybrid orbital of one carbon overlaps with the sp2 hybrid orbital of the other carbon. So remember, carbons, these are all sp2 hybrid orbitals. So the sp2 hybrid orbital, hydrogen has an s orbital, so they overlap, and so that's an sp2 and s overlap. In the middle, it's an sp2 hybrid orbital and another sp2 hybrid orbital from the other side, so it's an sp2 orbital. Both of them are sp2 overlapping with another sp2. And in the middle, it's a p orbital overlapping with another p orbital. Is that clear? This thing.
Yes.
And I'll talk. And I'll talk about. Hamza, mute kar do. It's. Use the spacebar to unmute when you. So the angles. Remember, it's fan shaped. So the angle is going to be 120 degrees, and the shape is going to be trigonal planar. Trigonal planar is the name that's used for fan shaped. And when you need to identify when is sp2 hybridization going to happen and so on. Now, usually the questions are very small, are really tiny about this one. They don't go into a lot of depth. But the understanding is very important, because sometimes a much bigger organic question would be dependent on this, like on your knowledge of this. Now let's talk about the third one, which is. So let's talk about the third one. So this one is. So this one is sp hybridization. The last one. Now sp hybridization is. It's going to happen when, first thing, when will it happen? When carbon is only bonded to two atoms. Or we can say carbon makes 2 pi bonds plus 2 sigma bonds. Or we can say that it makes 2 double bonds. Or it could be 1 single bond plus 1 triple bond. Or we can say that carbon is only bonded to 2 atoms. So that's the easiest way to figure out. So when it's bonded to 2 atoms. Examples for this would be you got a carbon dioxide molecule, an Ethene molecule, ethine is one molecule that carbon is only bonded to 2 atoms. So these are all molecules where carbon is only bonded to 2 atoms. Like this carbon atom, 2 atoms. This one, it's bonded to 2 atoms. This one is also, both of them are sp hybridized. They're only bonded to 2 atoms, and they are both forming 2 sigma bonds, double bond. So that's 2 sigma bonds, and 2 pi bonds. Over here, you got 2 pi bonds. Over here, even you got 2 pi bonds. So in this case, carbon is always forming 2 pi bonds. So we're going to talk about hybridization, which is kind of simple. In this case, since carbon is only bonded to 2 atoms, that means one of the atom over here on the right side, and the other atom would be on the left side. So you got these 2 atoms. One atom will pull carbon's 1 electron. So that electron is going to get attracted in this direction. The other atom is also going to pull an electron. So that electron is going to get pulled in the other direction. Now, the next part is, so carbon had 4 electrons, right? It had 2s, 2px1, 2py1 and 2pz1. So that means two of them have changed shape. They've become sp hybrid orbitals. So two of the electrons got pulled in different directions. So these two are now, their shape is different. So they're now referred to as sp hybrid orbitals. While the 2px and 2py and 2pz, they remain unchanged. Nothing happens to them. So I've got a 2py, and I'll have a 2pz as well, which would be on the z-axis. So imagine this as being the z-axis, like coming out of the page. So there's going to be another electron which would be on the 2pz axis. So two electrons got pulled in two different directions. They changed their shape, while the 2py and the 2pz, they're still as it is. Is this clear? This thing.
Yes.
So let's talk about how this bond, how would bonding happen? And let's try which molecule. I mean, we can try this one. We can think of this one. So both carbons are sp2 hybridized. So there's an H atom. The carbon atom is in the middle. One of the electron of carbon gets pulled by the hydrogen and overlaps with it. So that's one sigma bond. That's an sp hybrid orbital. The other electron gets pulled by the carbon on the other side. So it gets attracted by the carbon. One second. So it gets attracted by the carbon on the other side. And for the other carbon, it's exactly the same. So its electron gets attracted by hydrogen. So both carbons are at the moment sp hybridized. So I mean, this one electron gets pulled by one carbon, the other electron gets pulled by the hydrogen. Is this clear?
Yes, sir.
So carbon has two electrons left. So here's your 2py, right? And the other carbon atom also has a 2py left. What happens when you have two orbitals parallel to each other? They would form
A pi bond.
So they're going to form a pi bond. So there's a pi bond here, there's a pi bond over here, right? But then there's another orbital that is still left. And that orbital is on the z-axis. So think of it as the z-axis. So there's another orbital, but now imagine this coming towards you and going into the page. So there's this other orbital, and so this one into the board. So this is the z-axis, and let me shade the red one even just a second. So that's basically my so this So anyways, they're not even going to ask you about drawing this because it's too complicated. So that's one of my pi bonds. And what will the green ones do? They're also going to overlap, right? And they're going to overlap in front, and so overlapping will happen on the z-axis. So they're going to overlap in front of it and also on the backside. So something like this. So that's basically your triple bond now, because you had a sigma bond and now you've got two pi bonds. One of them is on the y-axis, like the y-axis, the red ones, they're overlapping, and the other one is on the z-axis. So it's overlapping in front of it and also behind it. Can you understand the three-dimensional diagram?
Yes.
Right. So this is sp hybridization, when carbon ends up making either a triple bond or two double bonds. So the carbon atom, one electron gets pulled by one carbon atom, the other one gets pulled by some other atom. So that's two sp hybridized orbitals, two of them, like the green ones over here. Then one of the orbital in the p remains unchanged, so it overlaps with the neighboring one and they end up forming pi bonds. One of the orbital on the z remains, so the z orbital and the z orbital of the other atom would also overlap and they would form another pi bond. So there's going to be two pi bonds in the middle. So over here, there are two pi bonds. There's a sigma bond right in the middle. This is sigma bond, and this is also a sigma bond. Is this clear?
Yes.
Yes, sir.
So anyway, so this one, no one is going to ask you to sketch this. What they can actually ask you is to sketch one of the pi bonds, and that part would be kind of easy, like just one pi bond. Most of the questions would just generally ask you to sketch one pi bond. You just have to, I mean, for that, even you don't even need to know this. You just need to know that whenever you have a double bond or a triple bond, that's where a pi bond is. So you just have to show this overlapping that we had earlier discussed about pi bonding. I mean, like if they talk about Ethene molecule, I mean, most questions would be kind of simple. If they talk about Ethene molecule and they ask you, I mean, they ask you to sketch just one pi bond. So all you have to do is that you've got HC and you've got N. And if you are just being asked to show one pi bond, that this is where you're going to show it. Draw two p orbitals parallel to each other and just show the overlapping that's going to happen. That's pretty much it. I mean, you just need to know or learn how to draw a pi bond. And then they can be very specific, like they can talk about what type of orbital overlap is happening over here. So you should know that this particular bond is, the hydrogen has an s orbital, the carbon has an sp hybrid orbital, because in this scenario, when carbon is only bonded to two atoms, it's sp hybrid orbitals that are making the sigma bonds. So these are the orbitals that are overlapping. Is this clear?
Yes.
Okay, so just remember, so I'll just quickly recap this. Carbon bonded to four atoms, that's and four single bonds. That is, or four sigma bonds, that's sp3 hybridized. All electrons get pulled in four different directions, and it's the sp3 hybrid orbitals that are bonding with whoever it's bonding to them, and it's overlapping with it. When carbon is only bonded to three atoms, that means three of the electrons, they become sp2 hybridized, and the fourth electron remains unchanged. The unchanged p orbital is the one that's involved in pi bonding, as shown over here. And the third scenario is when carbon is just bonded to two atoms. Then what happens is that two electrons, they become sp hybridized because they change shape, they get stretched in different directions. While the two unchanged p orbitals, they're involved in pi bonding. Like one forms pi bonds on the y-axis, the other one forms pi bonds on the z-axis. The one on the z-axis, they would overlap. And you just at any point, I mean, this drawing is obviously, it's never going to come in your exam. I mean, it's impossible to sketch that. This is what basic level drawing that they would expect from you. And you should know what type of hybridization is happening at any given point. So is this clear?
Sir, what will be the shape of sp hybridized?
The bonding angle, yeah.
So the angle that's going to be 180 degrees, and it's going to be linear because one atom is on the left side, the other atom is on the extreme right side, so the angle would be 180 degrees. Okay. Now, and sometimes they might extend hybridization. Remember, most of the time it's related to carbon, but sometimes they might extend this to oxygen and nitrogen as well. So you can make a more general rule that can be applied to oxygen and nitrogen as well. Okay, if you want to identify what hybridization is happening, so we can extend it to oxygen, nitrogen, and let's put carbon in it as well. Just remember, no pi bonds, that's sp3. I said now, you don't need to go into that much detail because the questions are not going to be that important, which is why I'm not going to discuss oxygen and nitrogen. You just need to know the knowledge that when oxygen and nitrogen are only making single bonds or sigma bonds, that is going to be sp3. When they make one pi bond, then that is sp2. And when they make two pi bonds, then that hybridization is sp. So you can have a more general rule and extend the same exact hybridization concept can be applied to oxygen and nitrogen as well. But for them, don't go into that much detail. I mean, they've asked questions, MCQs, but they were very basic MCQs, just asking about what type of hybridization are they having. I mean, for example, if I have this, so let's do some basic questions. Let's say I have this molecule. By just looking at the molecule, what hybridization is carbon?
sp2 hybridization.
Because it's making one pi bond, right? So this one is sp2. What about nitrogen over here? I mean, apply the same rule.
sp2.
Because it's making one pi bond, so that's sp2 as well. Remember, in a double bond, you have one pi bond. So whenever you have one pi bond, that's sp2. What about let's say I have this molecule. So the first carbon atom, it's not making any pi bonds. So what is that? That one is
sp3.
sp3.
What about the other two? What about nitrogen?
sp.
Okay, because it's making two pi bonds. Triple bond is one sigma bond plus two pi bonds. So that is going to be sp. And this one would also be sp hybridized carbon atom. Is that clear?
Yes, sir.
So about this, you should know, I mean, most of the questions are going to be really, really simple. We're out of time. Do you guys have 5 minutes? Or you have a class?
Yes, sir, we
5
have.
minutes is fine, sir.
Yeah.
Actually, just a few questions wanted to. Sorry. One second. So just quickly going through hybridization questions. Ethene, he's saying, is ethene going to have? Achha, he's saying what feature is present in both ethene and polyethylene. So I'll just quickly do that. Ethene is double bond, and polyethylene, on the other hand, one second. So polyethylene, on the other hand, is a bunch of carbon atoms. It's polymerized form of ethene, so they all link up, and the double bonds they break, and it's a big chain. So I mean, you can imagine the same thing repeating over and over again. Now this one. Are both carbon atoms sp2? What hybridization is over here?
sp2.
Yes. sp2.
Okay, this one is sp2. This one is, and what is the hybridization over here?
sp3.
Okay,
sp3.
sp3.
sp3. Okay, so this is wrong. This feature is not common to both. They don't. What feature is present in both? So that's not true. But anyways, do they both have sigma bonds?
Yes.
Yeah.
Yes.
Okay, so that is common in both. Do they both have pi bonds?
No.
This one has pi bonds. This one doesn't. And the angle 109. When did the angle 109 happen? In what hybridization?
sp3.
Tetrahedral.
sp3. sp2 was fan shaded. It was 120 degrees. So this is 109, but this is not. Achha, forget pi bonds hybridization. Just a second. So this one, they're very specific now. He's saying the double bond between the two carbon atoms in an ethene molecule consists of one sigma and one pi bond. Which orbitals overlap to form each of these bonds? So he's talking about ethene. We just did that, and he's talking about the double bond. So where's the ethene? I mean, this was the ethene molecule, right? So he's talking about the double bond in the middle. So who's forming the sigma bond over here? It's the sp2 hybridized orbitals overlapping, right? The two carbon atoms. Is that clear?
Yes.
And who's forming the pi bond? It's the p orbital, the unchanged p orbital overlap with the unchanged p orbital of the other atom. So the answer to that one would be the pi bond is between the p and p. And in an ethene molecule, it's going to be A. Is that clear?
Yes.
Yes.
So then you have this one. It's saying which contains a nitrogen atom which is sp hybridized. First one, NH3. I mean, I'm starting from D. Is it sp hybridized?
No.
No.
How many pi bonds for sp hybridization?
2.
I mean, we wrote
Oh,
this.
yeah.
We wrote over here. For sp you need 2 pi bonds, right? So what about HCN is this one? So is this nitrogen sp hybridized?
Yeah.
Yes.
Okay, that is.
Yes.
It's making 2 pi bonds. The other ones are more about sigma. But anyways, here's this is all about sigma and pi bonds. We'll do the other questions later on. Now the questions. Now remember one thing about this one. The questions can be really simple, or I mean, like really straightforward, just tiny, like really small questions. Even in the theory, you'll get just 1 or 2 mark questions at best. But sometimes what happens is that in organic chemistry, the entire question depends on your understanding of SP. Like they might ask you to identify a molecule, and it's a 10-mark question, and somewhere in the middle, they would give you a hint that it is SP hybridized, like one of the carbon is SP hybridized. Now, if you don't know what that carbon is, I mean, if it's SP hybridized, you should know that it should be making 2 double bonds, or it should be making 2 pi bonds, right? So the entire organic question would be dependent on this small information, which if you don't know, you wouldn't be able to answer. So direct questions would be very small. They would be just 1 or 2 marks. But indirect questions sometimes, not always, but sometimes the entire question becomes dependent on this, on your understanding of this. Is this clear?
Yes.
Yes.
Yes, sir.
So let's continue tomorrow. We'll do. Remember, this is just simple. Most questions would be. We'll do a couple of more questions in the next class as well. But remember, direct answer questions on this would be very, very small and very, very short. So we'll try and do shapes tomorrow of molecules, and hopefully we'll try and do intermolecular forces as well.
Okay, sir. Inshallah.
So,
Hafiz.
Okay.
take care.
Allah
Hafiz.
Yes.